This presentation is going to be Weir overflow rate math problems. As always, I preface I claim no ownership to any of the questions and material presented in this video, as everything I've found is sourced off the open internet. In the following slides, I have to the best of my knowledge presented the proper formulas and answers to the questions. This is a study guide for me, making these PowerPoints. It's helping cement the information in my mind, getting ready for my exam. If it helps you too, that's great. Like I always say, I'm in Florida, and in Florida they give you a formula sheet. It's 8 pages. We're doing Weir overflow, and that's going to be on page 5 of 8. I'll put the formulas as we go on each slide. So there's your Weir overflow rate. Like I try to always say, if your state gives you a formula sheet, you should familiarize yourself with it, so that way when you're taking a test, you're not scrambling around looking for these formulas. Question number 1. A rectangular clarifier has a weir length of 250 feet. What is the weir overflow rate in gallons per day per foot if the flow is 3.5 million gallons a day? I always like to do your known and your unknown. What you know is your weir length is 250 feet and your flow is 3.5 million gallons a day. What you don't know is your weir overflow. It means you're going to use the weir overflow rate gallon per day formula, which is total flow gallons per day divided by the length of the weir in feet. Well, we need to convert 3.5 million gallons a day to just million gallons. So 3.5 million gallons a day times a million with the 1m, so that the million cancels out and you're left with gallons a day. You get 3,500,000 gallons a day. Going to go ahead and plug our numbers into our formula because we already have our weir length in feet. So 3,500,000 gallons a day divided by 250 feet will give you a weir overflow rate of 14,000 gallons per day per foot. Question number 2. A rectangular clarifier has a weir length of 250 feet. What is the weir overflow rate in gallons per day per foot if the flow is 7.7 million gallons a day? What we know, the weir length is 250 feet. The flow is 7.7 million gallons a day. What we don't know is the Weir overflow rate. We're going to use the Weir overflow formula, which is the Weir overflow gallons per day per foot is equal to the total flow gallons per day divided by the length of the weir in feet. Well, our total flow needs to be in gallons per day, so we need to convert 7.7 million gallons a day to gallons per day. 7.7 million gallons a day times a million over the 1m, which will cancel out and give you 7,700,000 gallons per day. Add that into our formula. We already have our weir length in feet. It's 250 feet. You're going to do your division, and your answer is 30,800 gallons per day per foot. Question number 3. A circular clarifier has a weir length of 120 feet measured to the nearest foot. What is the weir overflow rate in gallons per day per foot if the flow is 2.34 million gallons a day? Alright, what you know is your weir length of 120 feet and your flow of 2.34 million gallons a day. Your unknown is your weir overflow rate. Overflow rate is still total flow gallons per day over the length of the weir. This is just a circle instead of a square, but the weir length is still given to you as 120 feet. Again, it's total flow gallons per day. We need to convert 2.34 million gallons a day to gallons per day. It's 2.34 mgd times 1 million over 1m. Cancel out the million gallons and just make it gallons per day. You get 2,340,000 gallons per day. Plug our information into the formula because we have it all. So 2,340,000 gallons per day divided by 120 feet gives you a Weir overflow rate of 19,500 gallons per day per foot. Question number 4. A rectangular clarifier has a weir length of 95.5 feet. What is the weir overflow rate in gallons per day per foot if the flow is 1.45 million gallons a day? Again, we pull up our knowns and unknowns. We know the weir length of 95.5 feet, the flow of 1.45 million gallons a day. We're still looking for the overflow rate. So the weir overflow rate, gallons per day per foot, is equal to total flow, gallons per day, divided by the length of the weir in feet. We need to convert our million gallons a day, gallons per day, 1.45 million gallons a day times a million over 1M, 1,450,000 gallons per day. Plug everything into our formula. So the 1,450,000 gallons per day divided by the weir length of 95.5 feet. Your weir overflow rate is 15,183 gallons per day per foot. Question number 5. What is the weir overflow rate gallons per day of a circular sedimentation basin that has a circumference at the weir of 300 feet? Assume that flow into the basin is at 400 gallons per minute and the basin is full. Alright, so we have the same kind of problem. It's worded a little different. We do our knowns and our unknowns. So what we know is the flow is 400 gallons per minute and the weir is going to be 300 feet because the weir is on the outside and it's the circumference of a circle. So it's the outside of the circle, so 300 feet. We're looking for the overflow rate in gallons per day. So this time we're going to have to convert gallons per minute to gallons per day. There are 1,440 minutes in a day. So if you multiply 400 gallons per minute times 1,440 minutes in a day, you get 576,000 gallons per day. Put that in our formula. Divide it by the 300 feet of the weir, and you get a weir overflow rate of 1,920 gallons per day per foot. Question number 6. Calculate the weir overflow rate for the sludge thickening tank with a single weir on the outer periphery of the basin. The tank has a diameter of 86 feet and is 12 feet deep. The flow into the tank is 0.2 mgd. Alright, so now this question is getting even more complicated and adding some more layers. So we always start with what we know and what we don't know. We know the diameter is 86 feet. The flow of 0.2 mgd. We do not know the weir overflow rate, and we don't know the length of the weir because it gave us the diameter. And the weir overflow rate still is the total flow gallons per day divided by the length of the weir in feet. Well, if the weir is the outer periphery part of a basin, that's the circumference. And to find the circumference of a circle, it's 3.14 times the diameter. The diameter is 86 feet. So we're going to multiply that by 3.14. Gives you the circumference of 270 feet. The length of the weir is the circumference. So you can plug that into your formula. We need the total flow in gallons per day. So 0.2 million gallons a day times a million gives you 200,000 gallons per day. Plug that into your formula. 200,000 gallons per day divided by 270 feet gives you a weir overflow rate of 740 gallons per day per foot. Like I said, same problem with the weir overflow rates, but you just add in other factors that you have to solve for to be able to punch in the numbers to your equation. Question number 7. A circular clarifier with a diameter of 108 feet has an effluent weir 2 feet from the outer wall. The flow into the clarifier is 0.75 mgd. Calculate the weir loading rate, gallon per day per foot. So now we have an added layer to this question. We're going to start with our known and our unknowns as always. You have a flow of 0.75 million gallons a day, a diameter of 180 feet, and the weir is 2 feet off the wall. Remember, the weir is going to be the circumference. So what we don't know is the overflow rate or the length of the weir. Now listen to the wording. The diameter is 180 feet, but the weir is 2 feet off the wall. All right, so here's a little circle I have going. So of course the diameter is the line from side to side. This is your diameter. But our weir is 2 feet off the wall. So you're going to have 2 feet off of each side of this wall. So to find the circumference is 3.14 times diameter, but you're going to have the inner circumference. So it's 2 feet off the wall. So you're going to be doing it for the blue circle. There's 2 feet on each side, so 108 feet minus 4 feet. It's going to give you a diameter of 104 feet for the inner weir times 3.14 gives you 327 feet. So the length of that weir is 327 feet. Total flow needs to be in gallons per day. 0.75 mgd times a million. 750,000 gallons per day. Plug that into your formula. Your weir overflow rate, 750,000 gallons per day divided by 327 feet is 2,294 gallons per day per foot. All right, so that was a couple questions on weir overloading. It's pretty simple and straightforward, the formula itself. The questions, they can start adding more and more variables that makes it more complicated. Advice I was given when doing weir overflow rate problems, calculating the circumference is key. Also the weirs, like if there's multiple weirs, are they double-sided, like the previous question, 2 feet from the outer wall. Pay attention to the units. They're looking for gallons per day, gallons per minute. All that's pretty important. Like I said, making these PowerPoints is helping me learn and cement all this information in my mind before I take my exam. And hopefully it helps you too. That'd be great. Thanks.